This is, we're still on Practice Exam 2, Section 2, Part B, and this video will cover number 5. Alright, so looking at number 5, it says that f of x is equal to 0 to x of g of t dt. Anytime you see that, all it's saying really is that the graph of g, which is down here, is also a graph of f prime. Remember, if you take the derivative of something like this, okay, and I'm going to go ahead and you plug in the upper limit and multiply by the derivative of the upper limit. So f prime of x is just going to be g of x. So this graph that says is the graph of g is also a graph of f prime. So it means we're going to be using our skills in reading a graph of a derivative. Okay, so part A is, probably the hardest one. Okay, B and C are easy on this one. You're going to know how to do those. Part A, it says find f of 3. Well, you can't just read the graph. This is a graph of f prime. So to get the original function, the value f of 3, what you have to do is, f of negative 3. What you have to do is go from where you start, negative 3, to 0, and, you start at 0 and you go back to negative 3. Of f prime of x dx. So you're going to find the area under the curve from 0 to negative 3. However, you have to put the negative number on bottom. It has to go from smaller to larger number. So in order to flip those numbers, we have to do this. We have to put a negative out front. So what you have to do then to get that is to find the area under the curve between 0 and negative 3. So that area and that area. So it's just two triangles. Alright, so for this triangle, you're going to be 1/2 times the base, which is 2, times, and here I'm going to put that bracket out front. Remember, we've got a negative there. So 1/2 times the base times the height, which is negative 2, plus the second triangle, which is above the x-axis. So that'd be 1/2 times the base of 1 times the height of 1. So that is negative. And then we would have negative 2 plus, the height on this second one is actually 2. I'll give you a chance to fix that real quick. So negative 2 plus 1, so that's going to be negative 1, which is 1. So if you can actually, from the graph of the derivative, figure out what f of negative 3 is. They also want to know f of 3. So it's a similar procedure. It's going to be from 0 to 3. And since we have them in the proper order, we don't have to put a negative out front, of f prime of x dx. So remember, integrating f prime of x would give us big f of x, the original. So we're going to look at the area under the curve for, I'll use a different color. What do we got here? We got blue. So that area and that area, that triangle. Okay, so you've got 1/2 times a base of 1 times a height of 2 for the first blue triangle, and then for the second one, 1/2. The base is 2 and the height is negative 1. Right? It goes below. So that's going to be 1, and then plus negative 1, which is 0. so f of 3 is 0. Alright, so that's new. It's not hard if you know how to do it, but we haven't done a ton of those. So I'll give you just a second to write that down. And then we'll get to a couple that are easy. You are going to get those quick. Okay, part B. Find all values between -3 and 3 that have a max and a min. Okay, so a min occurs where the graph of the derivative f prime goes from negative to positive. Okay, negative to positive. Well, where's it go negative to positive? Right here at -1, and that is it. So at x equals -1, you have a min. A max occurs where f prime goes from what? Positive to negative. Alright, well, where's that? Well, that's at 1. That's the only spot at 1. So x equals 1 is a max. And that's also your justification where you write those out. It says to justify your answers. Okay, so that one, you got to pick that one up because you might not have got part A. Okay. Part C, you also got to pick it up. Sorry, I keep bumping the stand. Alright, part C. Find all the values there where we have a change in concavity. Okay, a change in concavity occurs where the slope of f prime changes what? Signs. The slope changes sign, where it goes from a positive slope to a negative slope or vice versa. Okay, so where's that happen? Well, the first time it happens at 0, right? We went from a positive to a negative slope. So x equals 0. And then does it happen again? Yeah, we're negative, negative. Boom, at 2 we go positive. So 0 and 2, we have changes in concavity. We also would call those inflection points. Okay, so you can nab that one. Let's get part D. Part D is not too bad, but it's not exactly like one you've seen. It says, write an equation of the line tangent to the graph at x equals 1. Okay, so remember, we've got our form y minus y1 is equal to the slope times x minus x1. And we're talking about the equation of the tangent line to f. Okay, so first of all, what is our x value, x1? Well, x1 is just going to be 1. We have to figure out the y value when x is 1. We'll get that in a minute. What is our slope? Well, our slope is given by the graph. So what is the slope at x equals 1? We'll just read the graph. It is 0. Okay, when x is 1, the slope, f prime, is 0. So we have our m, we have our x1, we've got to get y1. That means we got to find f of 1. And we're going to use the procedure we did in part A. It's going to be, we're going to integrate from 0 to 1 of f prime of x dx, because when you integrate that, you get the parent function. That is going to be the area of this triangle right here, 1/2 times the base of 1 times the height of 2. So that's 1, which is our y value. So we will have y minus 1 is equal to 0 times x minus 1. So that is going to be y minus 1 is equal to 0 So it would be y is equal to 1. And I think if you just left it like this, you should get it. All right, but I went ahead and did a little bit there. So there you go. That is number 5. I think A and D up to this point would have been hard, but I hope B and C you could have just gotten right away. All right, so definitely one worth studying. And on the next video, we will do number 6 and finish this test out.